Nalla Narasimha Reddy, Education Society's Group of Institutions, Integrated Campus. This is Dr. G. Subbarao, Professor, working as Professor in Department of Civil Engineering. Welcome all the civil engineering candidates for this online session. I would like to explain about the topic weathering of rocks, its advantages and disadvantages. This is the topic, and weathering and its effect of weathering on a common rock. So, two topics are covered in this session: advantages and disadvantages of weathering from civil engineering point of view, and effect of weathering on a common rock, granite. Let us first start the topic advantages and disadvantages of weathering from civil engineering point of view. We know very well the meaning of weathering, the process by which rocks are broken down and decomposed by the external agencies of rain or temperature changes, etc. Otherwise, the definition weathering is defined as a process involving disintegration and decomposition of rocks. Coming to advantages of weathering from civil engineering point of view. Weathering certainly produces a soil which is very much essential for agricultural purpose and for the production of agricultural crops. Hence, weathering is very important point from agriculture point of view, not from civil engineering point of view. Weathering make the rocks into porous and permeable, so that it allows the movement of groundwater from civil engineering point of view, especially in hard rocks. If rocks are porous and permeable, then we can tap groundwater. So it allows the movement of groundwater. Sometimes economic minerals like bauxite are formed due to weathering. So oxidation of chemical weathering is also important for the formation of some of the ore deposits, particularly sulfide deposits. In such a way, weathering is also important. Similarly, there are some disadvantages of weathering from civil engineering point of view. Weathering reduces the strength, durability, and good appearance of the rocks. So, weathering is not a welcome process. Weathered rocks are usually unfit at the foundation in case of civil engineering structures like dams, reservoirs, bridges. So, foundation part is very, very important. If the rocks are weathered, that site is unfit for foundation purpose. Usually, weathered rocks are characterized by less compressive strength, and the durability also is less. That is the reason they are unfit for the formation of road metal or a building stone. If we see the picture, the left part is unweathered granite, that means it's a fresh rock, and right side, this is also a granitic rock, but it is totally weathered. So, in unweathered granitic rock, the feldspars are still fresh, whereas the feldspars are altered to kyalinite, that is clay, in the weathered granite part, which is shown in the right side. That's why strength becomes less, durability also becomes less. Hence, weathered rocks are unfit for the formation of road metal and also building stone. Weathered rocks are weak and they are unsuitable for tunneling. We can compare these two pictures. In the above picture, the tunnel is passing through a weathered rock where so much rock is excavated rather than the exact perimeter of the tunnel. If we see the tunnel in another picture where the perimeter is exact to the tunnel surface. Hence, fresh rocks are suitable for making tunnel, whereas weathered rocks are unsuitable for tunneling purpose. Suppose weathered zone is occurred in the upstream side of the dam or reservoir. So lot of silt accumulates in the upstream side of the reservoir dam, and hence the capacity of the reservoir reduces. So this is very clearly shown in the Almaty dam, where the silt is accumulated in the upstream side of the dam. Loose boulders, that is due to weathering, sometimes falls and cause for landslides, which is a civil engineering hazard, so that the roads are totally blocked if the landslides takes place. The picture, see, big boulders are falling and obstructing the traffic. This is due to weathering. So weathering leads to landslides. Importance of weathering with respect to dams, reservoirs, tunnels. Suppose a rock undergoes weathering, it leads to the formation of soil, which was discussed in the beginning. So that is useful for agriculture purpose. All the minerals which are present in rock, they do not undergo weathering equally. Some of the minerals undergo weathering in a speedy process, whereas some of the minerals will go moderately and some of the minerals never undergo weathering process. That's why the minerals which are present in a rock do not undergo weathering process equally. This weathering phenomena is depending on climatic conditions, composition of the rock, texture, and origin of rocks. The design and construction of civil engineering structures or projects, tunneling, slope, stability, and construction materials are all under influenced by the process of weathering. During the site investigations, For constructing a dam or reservoir, a civil engineer must necessarily to prepare a detailed weathering maps of the region and to determine the thickness of the weathered zone. These are the two important points which are to be remembered. One is preparation of weathering maps and the other one is to determine the thickness of the weathered zone in the site where a dam or reservoir is proposed. The design and construction of civil engineering structures or projects, tunneling, slope stability, etc. are all influenced by the process of weathering. Hence, the study of weathering is very, very important from civil engineering point of view. During site investigations for constructing a dam or reservoir, so a detailed weathering map of the region or of that particular area is to be analyzed as discussed earlier and to determine the thickness of the weathered zones. So this is an example where a weather map is prepared, which includes, of course, precipitation, temperature, wind, rainfall, etc. One is shown here, the rainfall data. Dam foundation generally requires hard rocks. There are varieties in dams: arch dam, buttress dam, earthen dams. In case of arch dam, foundation require fresh rock, whereas gravity and buttress dams require less weathered formations. However, in case of earthen dams, they can be constructed on weathered rocks. In a tunnel and an underground power stations, design and construction depends on type of rocks. Always a deep weathering condition creates serious problems in the roof and floor of a tunnel. This is the example. Ramam project includes 4.7 kilometer tunnel from Mung Khola, a distributary of the Godama river in Darjeeling, West Bengal. So where the lengthy tunnel, 4.7 kilometers tunnel, has a problem with the roof and the floor of a tunnel. In such a situation, it is mandatory to confirm the depth of weathering for implementation of some of the remedial measures. Highly weathered and nicest, highly weathered seas with heavy seepage and roof collapse along weathered zone has been reported from the main tunnel of Ramam hydroelectric project. So, weathered rock poses so many problems. If we consider effect of weathering on a common rock granite, what happens? Let us see the effect of weathering on usually available rock granite. Among the different types of rocks, granite is the most abundant rock in the surface, and hence granite is considered to analyze the process of weathering and its effect. In this session, granite usually consists of feldspars and quartz, along with some of the ancillary minerals of amphiboles, pyroxenes, biotite, muscovite, hematite, rutile, zircon, apatite, garnet. During the oxidation process in weathering, feldspars in granite converts into sericite and then to kyanite, thereby silica removed from the reaction of rain, water or groundwater. That means during the process of weathering, especially oxidation process, feldspars converts into sericite, then sericite into kaolinite, then kaolinite into silica removed from the reaction. Feldspars, sericite, how kaolinite is formed, shown. Weathering process, how it is taken, is shown in the picture. This the granite is decomposed, chemical weathering. This is also a picture of chemical weathering. Similarly, other acer minerals such as biotite or muscovite, if they weather due to hydrolysis process, they convert into kaolinite and release iron, potassium, magnesium into the surrounding soil as nutrients. So for agriculture purpose, that is good. Quartz minerals which are present in granite remain unchanged, whereas mica becomes chloride. That's what we discussed on decomposition. Pyroxene, if it is augite or diopside, decompose and pass into hornblende, is a amphibole mineral, otherwise break down into chloride. All these changes are due to weathering and causes for failure of civil engineering structures, and hence study of weathering of rocks is very, very important. And finally, geological considerations such as topography of the area, geomorphology of the site, impact of geological structures such as folds, faults, joints, etc., lithology of the formations in the available site, identification of weak zones in that particular area play a very important role in civil engineering projects.